Let's see how you did solving this last problem with the position time graph. First questions are the same as the ones that we did previously. We need to find the average velocity of the SUV from 0 to 1 second. So I'm going to highlight that segment of the graph in blue here for you. We're looking at the slope of that segment. It looks like this graph has a positive slope, so I'm going to expect that my velocity would be a positive number. Velocity is slope, so take your position of the SUV at 1 second, which is 15 meters, and subtract it from the initial position at 0 seconds, which is 0 meters. When you divide by the time period, you end up with a velocity ratio that is 15 meters in 1 second, and you can just go ahead and write that as 15 meters per second. That is a large positive number, which matches the slope of the graph that we see. I'm going to change colors here. Let's use the green. The next segment is from 1 to 4 seconds, highlighted in green. Now, when you look at that slope on the position time graph, you should think to yourself, well, that's a negative slope. So let's calculate the average velocity for that time and see if we actually get a negative value. When you do slope, remember this change in position is always final minus initial. So I'm going to take the position at 4 seconds, which is 0 meters, and I'm going to subtract it from the position at 1 second, which is 15 meters. When you subtract 0 minus 15 meters, you get a displacement of negative 15 meters in 3 seconds. You can go ahead and divide that out if you like. You get an average velocity of negative 5 meters per second, and that negative does match what we predicted from the slope of the graph. Now let's do the average velocity of the entire ride for the SUV. I'm going to take the final minus initial displacement. The velocity depends on doing x final minus x initial over t final minus t initial. So if you look, the final position of the car at 4 seconds is 0 meters. And the initial position of the car at 0 seconds is at 0 meters also. When you subtract and divide that out, you get an average velocity of 0 meters in 4 seconds, which is 0 meters per second. So why is the average velocity for the entire trip 0 meters per second, but you know that the car does have a positive velocity for 1 second and a negative velocity for 1 to 4 seconds? Well, remember that average velocity is just the difference in the final and the initial positions. The pathway through the middle of the graph doesn't make a difference. If we were to watch this SUV in real life, what we would see is that the car moves forward for 1 second, and then it moves in reverse for 3 seconds. So it ends up in the same location that it started. It just happens 4 seconds later. All right, to answer this last question, what is the instantaneous velocity for the SUV at 3 seconds? We're going to have to draw that velocity time graph. So remember what happened on the previous problems. We're going to take the slope of the position time graph to give us the velocity values. Okay, so if you look at the blue segment, this blue segment has a slope of 15 meters per second, and it covers a time span of 1 second. So I'm going to come to my velocity graph. I'm going to graph a value of 15 meters per second for 1 second of time. And then the green segment of the position time graph has a slope of negative 5 meters per second. So I'm going to come to my velocity time graph, and I'm going to graph a velocity value of negative 5 meters per second for 3 seconds, and the final time is 4 seconds. Again, if you want to connect these with a dotted line or no line at all, either way is fine. So we see that the car is moving very quickly forwards and then slower, but in a negative direction. So I hope that you did a good job on that. Make any corrections in a different colored pen or pencil so that you can reflect on it and study with it later. and write down any questions you have, and we'll talk about it next time we're together. Good luck!